ahead and get started. All right, everybody, thank you and welcome to LlamaIndex, how to use LLMs to interface with multiple data sources. My name is Greg Loughnane, and I'm the founder and CEO of the AI Makerspace, an online community focused on accelerating learning for data scientists and machine learning engineers who want to build generative AI and LLM applications that create real value. We really appreciate you taking the time to join us for today's event. Today, you'll learn all about the power of LlamaIndex, and we'll answer the question asked everywhere around the world right now, namely, can we query SQL with natural language? Hint, the answer is yes, we can. We'll also combine qualitative and quantitative information based on questions asked in natural language. In other words, the holy grail of business value today, ChatGPT for your data. Let's get indexing and querying with LlamaIndex. If you hear anything during our event that prompts a question, please follow the Slido link that we'll put up on the screen now, and we will make sure to get to any questions asked in the Q&A portion of today's event. As usual, if you've seen us before, I'm excited to welcome my good friend, colleague, and LLM wizard, Chris Alexiuk, to the stage today, as we'll be working as a team to deliver this lesson. Chris is the founding machine learning engineer at Ox, getox.ai, and head of LLMs at the AI Makerspace. He's an experienced online instructor, curriculum developer, and YouTube creator. He's always building, shipping, and sharing his work. Chris, you ready to do this with Data Phoenix today, man?
You know I'm ready to do this with Data Phoenix, man.
That's right. We got the Phoenix jersey going today. That's a little foreshadowing of what you're going to see in today's event. Chris, we'll see you back up on stage in just a minute as we get started with the code. Awesome. So one quick note on the flow of today's event, I'll be sharing high-level concepts as an introduction to the coding demos that Chris will be running. So with that, we'll get right into it. Today, we're learning all about LlamaIndex. What is LlamaIndex? That's the first question we're going to answer. We're also going to leverage a new tool that you've probably heard of before, one of the hottest vector database companies out there on the market, Pinecone. And we're going to build a really, really cool setup of disparate data sources and learn how to query really complex indexes in simple natural language. We'll learn each piece of the stack that we need to do this as we move through today's event. And spoiler alert, we're going to have some hockey data that we're going to learn about LlamaIndex with today. All right, so what is LlamaIndex? Well, it's a data framework, and it's all about if you've got a bunch of disparate sources of data, if you've got your own private data, if you want to figure out a way to interact with it and combine really interesting qualitative, quantitative, other sources of information, this is a great tool for you to pick up and learn how to use today. The base LLM, the default LLM, I should say, within LlamaIndex is the Text DaVinci 003 model, the precursor to GPT 3.5 from OpenAI. But today we're going to leverage the GPT-4 model because it tends to be a little bit better at writing SQL queries from natural language. So we'll see how that works by the end of today's event. Recall, if you've seen this before, how to build a vector store or vector database. If you haven't seen this before, if you haven't messed with LangChain or any other tools that are in that LLM Ops space where you're trying to build out a vector database, there's some really clear steps that you have to take. This is all about essentially taking words from a document, turning those words into numbers, putting them in a vector format, and storing those vectors in a database. The steps for this are load the document, split the documents into chunks, create embeddings for each chunk, store everything in a vector store, and then wrap a retriever around that vector store. And so these steps are not different whether you're using LangChain, LlamaIndex, or any other tool that you might build out a vector store with. We will go through this process today, but it's not the only process we're going to go through. There are some details within LlamaIndex that are different. For instance, if you've used LangChain before, the idea of a node is one of the key primary ideas within LlamaIndex that you're going to want to familiarize yourself with. Nodes are first-class citizens, according to LlamaIndex. And a node is not anything super complicated. It's simply one of the chunks that we split up the document into in the first place. Those chunks we call nodes within LlamaIndex, and those nodes are what then get put together within a vector store index or a vector database. Each chunk, each node inherits the metadata from the document from whence it came. And during query, you're going to ask a question in natural language. That question is going to be converted into a vector. That vector is going to then go into the vector store index, the vector database, and it's going to look to see what other vectors within the vector store are similar to that vector. It's looking for a similarity between the query and the source information. It's going to fetch the top K most similar vectors, and then it's going to take those vectors and it's going to pass them through a really great response synthesis module that's built into LlamaIndex. So this is all really well set up and abstracted for you beautifully by this tool. And this is kind of what we're going to go through today. As we get started, we need to see how LlamaIndex is set up programmatically. And for that, we've got the LLM wizard himself, Chris, who's going to show us.
Yes, thanks, Greg. So first thing we need to do when we're working with LlamaIndex is set up some kind of configurations. So as Greg was mentioning, we are not going to be leveraging the default LLM, which is DaVinci. We're going to instead be using GPT-4, and this is just relating to the fact that it writes great SQL queries, and so we're going to leverage it today. You can use any kind of model with LlamaIndex, open source, closed source, API, non-API, totally up to you. We're just doing GPT-4 for the demonstration. It works well with GPT-3 Turbo, but that's it. We have some boilerplate to do. This is just relating to the fact that we're running this in a notebook, and then we have some basic logging that we can use in order to ensure that we have coherent logs if there are ever any crashes, mistakes, or exceptions. Before we begin using anything in Python at first, we have to get our dependencies, so we're just going to grab them with our pip install here. And again, you know, it's going to use text DaVinci, but we're going to change that. So we use our API key and we modify our model here to GPT-4. Now you'll notice I'm doing some general configurations and then some vector store configurations. The idea is it's a lot of the processes in this notebook rely on the LLM being modified and the chunk size being set. Now, what you'll notice is that we have this service context. That is going to act as our configuration that we can pass around into the various tools that we're going to be using today. We could use a global setting here, but we're just going to use the service context so we can have visibility as to where we need that context. You'll also notice that we're using our LangChain helpers. That's because LlamaIndex is quite tied to LangChain, right? So it borrows a lot of tools from LangChain. We're using the token text splitter, which means that this number here doesn't represent character length, but in fact tokens. And we are using our text splitter and node parser that is set up with that chunk size so that we can properly turn our data into nodes later on. But before we start setting up Pinecone, we're going to pass it back to Greg to hear a little bit more.
Awesome, Chris. Okay, so we've got our LlamaIndex parameters all set up, and now it's time to go ahead and get our Pinecone parameters all set up. So what is Pinecone? Well, Pinecone is a company created in 2021, and recently in April 2023, they really stunned the entire generative AI market with a $100 million Series B on a $750 million valuation that was announced. It is the largest investment that we've seen in the vector database space so far. And really, this is because everyone acknowledges that the vector databases are going to be a key component of that LLM Ops infrastructure stack as people continue to build out complex LLM applications. According to Pinecone, it's really easy to maintain long-term memory if you're building out AI and LLM applications. So that means sort of memory across many different conversations, for instance, rather than across one conversation. They also apparently are able to provide very low latency at the scale of billions of vectors, which sounds pretty cool to us. And according to LangChain, when you should choose Pinecone is when you're looking for a production-ready vector store that you don't have to worry about hosting yourself. That's when you should think about Pinecone. And, you know, specifically as we drill down into some of the details that we need to get set up, we want to first of all choose the dimensions of our vectors that we're going to put in our vector store index here. We want to choose the similarity metric that we're going to use to find and retrieve other vectors within based on our query. And now the key abstraction in Pinecone that we want to learn, just as node was very important in LlamaIndex, pod is extremely important within Pinecone. And a pod is just a pre-configured unit of hardware for running a Pinecone service. It's just sort of an idea that we need to become familiar with within Pinecone. And the types of pods are very important. The type that we're going to use today is called the P1. That's got a capacity of about 1 million vectors of dimensions 768. You'll see our dimensions are a little bit different today, but I think you'll be able to easily do the math. And then apparently these are ideal for very low latency. And so it works very, very fast. With that, we're going to see exactly how this looks programmatically in code as Chris gets our Pinecone set up. Let's see it from here, Chris.
So with Pinecone, what we're going to do is we're going to go ahead and set up a couple dependencies. Number one, we're going to set up the client. This is important because we need to be able to access it. And we're going to grab transformers because, as mentioned earlier, we're going to be using tokens, and so we need something to tokenize. When we're looking at our Pinecone setup, it's fairly straightforward. We have our API key, which we can get for free from Pinecone using the link in the notebook here. We're going to set up our environment or our project. Our project is being set up in this US West GCP free region. So we get one pod for free with Pinecone, which is fantastic. Then you'll notice that we're going to create an index in that project called Quick Start with dimension 1536. The astute among you will probably recognize this as Ada's embedding dimension. That's OpenAI's embeddings model. We're going to use Euclidean distance as our distance measure, and we're going to use this pod type of P1. So now that we have that set up, it's going to take a while if you're running this for the first time, to be clear. So do be patient. It's not bugged. It just takes a little while to set things up. Once we have it set up, though, we can go ahead and we can associate it with this Pinecone index variable so we can leverage it in the future. Now that we've kind of got the thing set up on the Pinecone side, we need to take that from kind of an idea of an index to setting up to be a vector store. We're going to do that by passing the index into our Pinecone vector store class, along with the namespace we want to use, which in this case is just going to be Wikipedia team info. Spoiler alert, we're going to be using some Wikipedia articles. We can also use this storage context in order to add additional storage. So, right, without setting up this storage piece, we're unfortunately not going to be able to put things in our Pinecone vector store, which is not ideal. Once we have the storage context set up, we can go ahead and add our vector store index. And so this is what's going to let us shove nodes into this index that we're going to add later programmatically. And that is it to set up Pinecone. Relatively painless process. And the next thing we're going to do is move into some data. But before we do that, we're going to hear a little bit more from Greg.
Awesome, Chris. So we got Pinecone set up. We've got LlamaIndex set up. Now let's see how we're actually going to get this data and where it's coming from, what it looks like, where we're going from here. All right. So the data that we want to look at is going to be NHL data. We're going to take tabular data and we're going to look at NHL team stats. And you notice here, in this CSV file, we've got 98.81 megabytes of CSV team stats. We've got some big data here, some relatively big data, and by CSV standards. And then we've got some player bio data as well. So what we're going to do is we're going to take the CSV data, we're going to create a SQL database with 2 tables, one for each CSV file. Then in terms of the natural language data, we're going to use the Wikipedia team info data, and we're going to take the natural language, the words, we're going to turn them into numbers, into vectors, put them into a vector store. And it's the contextual data that is the data that's going to allow us to answer the question like, what the heck is going on in this picture right here? For those of you NHL fans out there, you may already know, but for the rest of you, a little bit more like me, a little bit not in the loop, you may need a little help from the AI today and from LlamaIndex. So this is the data that we're going to have to sort of get into the appropriate form. We're going to have to do a little data cleansing, a little classic EDA, and then we're going to create the database, and then we're going to create the vector store as we get our indexes set up. Chris is going to show us how to do this right now. It's time to get data centric. Chris?
Yes, thank you, Greg. So we're just going to be collecting some data, doing a little bit of processing so that we can have it in the format we want, so we can carry on with the rest of LlamaIndex. So brief stop in data center land here. Now, like Greg said, we're going to grab a absolutely massive CSV at 98.81 megabytes. It's got a lot of rows, got a lot of columns. The idea is we're getting this data from MoneyPuck, which is going to have historic team data for the last few seasons of hockey, so back to the 08 season. We're also going to grab the biographic player table. So this is biographic information about various players, so like their age, where they're from, stuff like that. Now that we have these CSV files, we want to convert them into a SQL database. We're going to do that through the intermediary of pandas. So we're going to grab SQL Alchemy here as a requirement, which is a fantastic tool in Python for working with SQL. We are going to read our CSV into pandas, and we're going to do a little bit of modification of these columns. So these columns are a little bit generic and might clash with some of our other columns. So we're going to do some quick renaming, and then we're going to do the same exact process for our player tables. So we're going to load it into pandas, and we're going to change some of the columns around so that instead of having 2 different tables with the column name, we'll just have player name, player position, player team. This is to prevent issues later on when we're writing our SQL queries. Now, next up, we need to actually create our SQL engine, which we're going to do using SQL Alchemy. You'll notice that this memory flag means that we're going to do this in memory, so we're not persisting this. If you were out in industry or in the wild doing work, right, you would already have a SQL database that you'd be leveraging, so you wouldn't have to do this step. But of course, we needed to create one in Colab, so here we go. We are going to use the pandas library to just cast our data frame to SQL, where we pass our engine created above, as well as our tables that we want to convert to SQL. Let's make sure it works by running a select. So we're just going to select player name, position, and team from all player data, where their name is Aaron Dell, and we get San Jose goalie Aaron Dell. Remember, this goes back to 2008, so this is historic data. Yes, that's great, and we're very happy. Now, in order to grab some semantic information, let's go ahead and grab some information from various teams' Wikipedia pages. So we're going to use the Wikipedia library to do this. First of all, we're going to need all of the team names. We can just select those from our newly created SQL database. We get a big list. We're going to check to make sure that's equal to 33, since there are 32 teams in the NHL, but Atlanta moved to Winnipeg, and this happened post the 08 season. So technically, Atlanta and Winnipeg, while they were the same team, are represented as two different teams. So we should expect 33 teams. We see that there are way too many teams. And when we look at this list, we are able to see why. Okay, we have these initials, so we just need to clean those out. And then now that we've cleaned those out, we can go ahead and disambiguate those initialisms to the actual team names, which we just do using very naive and straightforward string parsing. Nothing much more to say about that. And then we're going to use the LlamaIndex reader, Wikipedia reader, to load all of that data into an object of documents. So this is going to hold a bunch of different documents. Basically, every entry in this list called Wikidocs is going to be a different document, which is going to represent an entire article from Wikipedia about the team. We have to include the autosuggest false parameter here, because if we don't, it might autosuggest a correction, at which point we're not really going to be searching our teams, and so we want to avoid that. But that is it. I mean, that is loading all of our data. So we now have a list of Wikipedia articles with some metadata, as well as a SQL database composed of those CSV files. And so the next step will be to create an index, which we'll hear more from Greg about before we see it in the code.
Awesome stuff, Chris. All right, so we took our data-centric approach. We got all of our data into the SQL tables. We now have LlamaIndex set up. We've got Pinecone set up. We've got our data set up. And now it's time to put the index in LlamaIndex and build out our indexes. Now, first, recall how to build a vector store index. We need to load the documents. We need to split the docs into chunks. We need to create embeddings, build out that vector store, and then set up our retriever that wraps around the vector store. This is going to be what we do with the Wikipedia data. And then with the SQL data, what we're going to do is we're going to directly turn that database into an index using tools within LlamaIndex. So what are these tools? Well, for the tabular data and for the contextual data, they're going to be a little bit different, but they're going to include these fundamental abstractions, these tools within the LlamaIndex framework. Really, this is where the magic happens. With the retrievers, and especially with the query engines, this is where LlamaIndex really shines. So this query engine interface that allows us to ask questions over different disparate types of data, this is really, really the thing that LlamaIndex that you should think of when you think of LlamaIndex. Yes, there are nodes, but this is the core idea, is the query engine. Just like when we think of chains, when we think of LangChain, we need to think of query engines when we think of LlamaIndex. And so when we go to set up our indexes, we go to set up our retrievers and query engines. What that actually will look like is the indexes are going to be set up just as the way we've been talking about. We're going to set up a SQL database index, and we're going to set up a vector store index. Then we get to the query engine side of things. And this is where LlamaIndex really has some awesome tools. And this NLSQL table query engine, I'll let you guys guess what is actually going on here, but it's pretty magical that this is a simple call and a built-in tool that works really well when connected to the right LLM. This again gets us into this space of what can we actually build with the right LLM and the right infrastructure tooling. And contextually, what we're going to do is we're going to set up that retriever, and we're going to put the query engine in place to be able to leverage the retriever. So pretty simple. We're going to see how this works in code. This is really, again, where the crux of LlamaIndex lies, is in the query engines. This is where you're going to be able to harness the power of LlamaIndex versus really no other tool out there today. And if you're going to start building, we recommend really getting to the point where you're building with these query engines. Otherwise, you're not quite going end to end through LlamaIndex. So Chris is going to take us all the way home, and all the way home is going to look like a simple line of code that clearly combines the SQL tool with the vector tool and gives some service context. So everything is going to be baked into this very last line of code as we put everything together. And we're going to be able to answer questions. Questions like, well, what's going on here exactly? And more interesting questions that combine the SQL data, the tabular data, the quantitative data with the qualitative context. So Chris, show us end to end how this looks like in action.
Yes, you bet. Okay, so this is, we did a lot of pre-work. We did some data collection, data processing, all this other stuff. Okay, fine. Well, now it's time for the kind of real work to begin, and then the magic can happen. So first thing we need to do is create some indexes, which you can just think of, like Greg said, these are stores of data that we can query using programmatic tools. First thing we're going to do is set up a SQL index. So in order to start that, we need to convert our SQL database into a format accessible by LlamaIndex. So we're going to use the LlamaIndex SQL database tool to do that, which we can see here. We pass in our engine and we tell it what tables we want to include. One of the things I want to point out is that while we're only using one SQL database here today, or one Wikipedia source, or one kind of contextual source, we could use many more. Right? It is not something that we need to be too worried about to add more things. So if we wanted if we had tables that we could contextually group, and then we had others that we wanted to be in a different contextual group, we could do that, no probs. But we're just going to walk through a fairly simplified example today so you can see how the flow works. Once we have our SQL database in a format that's acceptable to LlamaIndex, we're going to create this NL SQL table query engine, which is, of course, natural language to SQL table query engine. So this is what's going to let us wrap our database in something that allows us to make intelligent queries across it. So this understands metadata about our tables, like what the columns are called, all kinds of different things that will help us to understand how best we can create SQL queries. And so all that looks like in code, of course, is we pass in this LlamaIndex SQL database and what tables we want it to use. So, I mean, it's impressive, it's fantastic, it's powerful, and it's this code right here. Now that we have the natural language to SQL query tool set up, we can go ahead and set up our vector store. This is pretty straightforward, right? So as Greg discussed, the idea of nodes are very important. So we have these documents. They're quite large, right? Quite a lot of text, in a Wikipedia article. And so we want to partition those intelligently. So we're going to use this idea of nodes. And the reason nodes are so powerful in LlamaIndex is because there's a number of different ways we can structure them. As opposed to some of the LangChain processes, which tend to be very flat, we can have some fairly vertical data structures for our indices in LlamaIndex. So you can use tree hierarchies or more. Today, we're just going to use some defaults. So it is going to be relatively flat, but it doesn't need to be. You'll notice, though, that each of our wiki docs and team lists is zipped up into a list, and we loop through that. And we're going to split our nodes based on each article. So we're going to use that text splitter as part of our node parser. So that's 2048 tokens per chunk, as we set up in our service context earlier. And this node parser is just going to go ahead and split all of that. Fantastic. And then we're going to attach some metadata to each of those nodes to allow for easy querying or filtering if it was deemed necessary. Once we have each of the articles split into nodes and associated with metadata, we're going to go ahead and insert those nodes into our vector index. You can see here that we're inserting 8 nodes. So this article got split into 8 nodes, this one into 8, this one into 4, this one into 12. It goes on. There's one of these for each of the articles that we collected. And at the end of the day, we wind up with that all this information in our vector index. Now we can move on to set up our query engines. As Greg discussed, this is kind of like where the quote unquote where the magic happens, right? So this is where we go from just having an index, which is dope, and having an SQL database that we can query with natural language to communicating with it through the LLM, right? So first things first, we're going to do a little bit of pre-setup again. You'll notice a lot of this is setup, right? So that's important because metadata is pretty crucial in the LlamaIndex ecosystem. And so we want to make sure we set everything up properly and with enough and sufficient metadata to have a pleasant experience for our users. So we're going to set up some vector store info. This is just going to tell us what this content is all about. It's going to tell us what metadata is associated with it. And that includes the name of the NHL team. And this is so that we know how to query this, and that's all we need to do. In terms of our team vector auto retriever, this is basically going to be what lets us ask our index for context. So it's similar to get relevant documents in LangChain, where we're able to send a query through the vector index auto retriever and we'll receive back nodes that are relevant to our query. We're going to convert that into a retriever query engine. So not only will this let us query for context and get documents back, but it will add a layer where it processes that information through the LLM. So let's say we have a lot of documents about various LaCroix flavors, and we queried, how many calories are in lime or whatever. It would search out lime and then answer our question using that context. So this is the way that this is being referred to in kind of popular language is retrieval augmented generation. So this is where that step takes place. And now we have our database. We have the ability to query it with natural language, and we have a vector store that we can query with natural language that will answer questions. So at that point, we are ready to move on and create some tools. Now, these tools are what's going to let us leverage these as part of a more complex system. So we're going to set up a query engine tool for our SQL query engine. We're going to add this description explaining what it is useful for. So it's useful for translating a natural language query into an SQL query over tables containing. And then it gives us, or not it, we give it the information, what those tables are and what they pertain to. And then we do the same thing for our query, or for our vector store, or our retrieval query engine, which is, we say it's useful for answering semantic questions about NHL hockey teams. So when a query comes into our pipeline, these descriptions are going to help our LLM decide which tool is best for the job. And so you can see here that we have this SQL auto vector query engine, which is the process that's going to help us to make that decision of which tool to use, then leverage that tool So it will execute that tool pipeline. Then it will receive a response and make decisions based on that response. Very similar to LangChain agents, though implemented in a slightly different way. You'll notice as well that we're passing the service context again. That's what we set up at the beginning. That contains our model, that contains our chunk size. Again, we could have set up a global context, but it's nice to see where we're putting in the service context, where it matters, and where you might want to change or modify it. So now that that's all done, and that's a lot, I know, we're good. We're done though. I mean, this is like Greg said, this is a line of code that matters, and we can now move on to seeing how this thing works, right? So we just ask a simple query: what team has the most points? It enters the pipeline. The decision is made to use the query SQL database, and it builds a query, and that query is SQL, and it is executed on our database, and information is retrieved, returned to the LLM, and the LLM decides, I don't need to convert this and ask anything else. This is the answer to the question. Let's return it to the user. And we get the response of the team with the most points is the Pittsburgh Penguins with a total of a lot of points. Several players contributed to this high score, including notable names such as Mario Lemieux, Jaromir Jagr, Sidney Crosby. I mean, this is true, though, to be clear, not technically true. Mario Lemieux did not contribute to this particular score. This only goes back to the 2008 season. And this is based on, context that the LLM has that it's injected for us. So the reason the points are so high, of course, is because it's many seasons worth of hockey. So that's not so bad. Let's see if we can do better, though, right? So let's ask, who is the oldest current player on the Winnipeg Jets? And we get another SQL query. However, you'll notice that in this query, we use the all-team data table. In this query, we're using all-player data. So you'll notice it's intelligently selecting the table that is most likely to answer the query. When I say intelligently, of course, I mean it's an LLM, so it's not technically intelligent, but it is doing good to select the right table. And we get that the oldest current player in the Winnipeg Jets is Matthew Perreault, and we get that answer. It doesn't need additional context. That's it. Now, let's ask another query and see how it can handle this one, which is, how old was the Winnipeg Jets captain in 2018? Will they be playing with the Jets in 2023? You'll notice that this SQL query is, I'm not going to say it's like an advanced SQL query, but it's definitely past the junior SQL query, I would say. We're doing a join, right? We haven't wrote a single line of SQL to do this. It's doing that all together. It understands the tables, understands the columns. It understands everything that it needs to write this. It knows that the position is characterized by the letter C for captain. It knows all this from that metadata that it consumed when we built that SQL query engine. So it gets Blake Wheeler, unclear if he's going to be playing. So because it's unclear, the LLM decides, well, maybe we should just get the information for Wikipedia then. So it goes ahead and transforms this response into a query that could be used to query the semantic information. However, the Wikipedia article doesn't contain information about Wheeler's recent exit, and so it doesn't collect it there. This is preferred because it didn't try to make it up. It says, sorry, can't find it. It's the expected behavior. But Wheels is leaving, so if you're a Jets fan, there you go. Lastly, let's ask a purely semantic question. What special traditions do the Winnipeg Jets fans have during the playoffs? Which we receive a purely semantic response. So it doesn't query the SQL database because it doesn't think it can find information there. And so we go straight to Wikipedia articles, and we get a fairly robust and excellent response saying that the Jets have a special tradition called the whiteout during the playoffs. Dates back to a old feud where all the Jets fans will wear white. It was a response to the sea of red from the Flames fans. So it gives us tons of information. And again, this is that the ability for it to understand when it should be using each tool is what really makes this incredible, and the fact that we don't have to write SQL queries for this data is fantastic. But with that, I will send it back to Greg, and that wraps up our code demonstration for today.
Chris, awesome, man. That was really, really cool to see that LlamaIndex was able to do so many things once we got it set up. You know, really, we saw it was able to semantically answer questions. We solved the mystery. What is going on here? Well, apparently it's called the Winnipeg Whiteout. So for all of you Jets fans out there, you already knew that, but the rest of us, including myself, we learned something new about hockey today. Very cool. Thanks, LlamaIndex. And then we also saw that we can even do SQL joins. I mean, let's not like understate how awesome this is, that this was able to actually occur with a simple natural language question. It may not work perfectly in all cases, but this is definitely something, I know Chris may not consider it advanced, but I would certainly consider it an advanced SQL query for my particular level of being able to just generate SQL queries from scratch. And I'm sure many of you would as well. So this is really, you know, one of the key things people are asking for out there in the world today. Can I use natural language to interface with my databases? Can I leverage this for my product managers, for my business analysts, for people on my team that don't know how to write SQL? And it turns out that the answer is yes already today. And it's not quite as complicated as many people might think. Link the LLM up with the LlamaIndex set of query engines, and voila, you're good to go. You know, I think this is amazing technology, and we believe more people need to know about this. So, you know, in conclusion, LlamaIndex, you know, we've concluded on our side, this is a powerhouse tool. There's a reason why they got $8.5 million right after LangChain got 10. People are noticing that this is going to be a really, really important step forward in LLM ops and in building complex LLM applications. We see that it can even do joins, it can combine data sources, and it can provide quantitative answers with context. That is so, so cool. So if you've learned LangChain already, definitely pick up LlamaIndex next and start thinking, what could you build with this tool today? Because I guarantee if you're currently employed in any business, there is a business use case for what we showed here today. So with that, I want to encourage everybody to go ahead and ask more questions. Thank you all. I'm going to pull Chris back up on the stage now. We're going to go through the Q&A in Slido together. And if you have a question, please go ahead and scan that QR code link in the top of the screen here, and we will make sure that we get to it. Chris, welcome back, man. That was awesome. All right, here we go. Here we go, my dude. Okay, the number one top voted question is, what vector database would you recommend? How different are they? And when are you going to pick up one versus another?
Yeah, I mean, ultimately, it's a rather complex business choice. It's not really a technical choice at this point for the most part. I mean, there are some options that you're definitely not going to use, like you know, Chroma has telemetry involved. If telemetry is a blocker, you can't be using Chroma. If you can't be using outside information, you're locked out of that kind of Pinecone ecosystem. I would say, though, for most businesses, you're going to want to stick with whatever implementation of a vector database exists within your cloud suite. So GCP, AWS, whatever cloud suite you're partnered with. And if you can't do that, something like Pinecone is an excellent tool. It is not super expensive, and so it's a great tool. I would say if you're getting started, that's the easiest one to get started with. If you want that managed experience, but if you're going local, go Chrome all day. It's easy. It's the default LangChain and does it all for you.
Awesome, awesome. Pinecone, great place to get started. So you can use some of the tools that we showed today to go ahead and get started on your own. We did share the link to the notebook, and I believe that we will do our best to make sure that we share that again in case you missed it. So notebook, good to go. Question, I have my own knowledge base as a set of articles, not question and answer. How can I leverage that with LlamaIndex as opposed to Wiki, which had its support module? Is the question clear, Chris?
It is, yeah. So there are tons of loaders in LlamaIndex. There's text loaders. In fact, there's every single loader that exists in LangChain. So PDF, text, directories filled with random files that can be in some way clunged into text, images, it doesn't matter. LlamaIndex has the ability to adapt to whatever you feed it. You can go to the Llama Hub, which has a number of community-built adapters for a number of, if you want to attach it to Google Drive, if you want to, there's an adapter for that. So absolutely, you can use whatever data set you have. There's some kind of adapter. If you want to use raw CSV, if you want to, again, if you can dream it, you can attach it to Llama. The only thing you really have to do is get that information at the end of the day into text and then send it to a directory that Llama can see. And if you can do that, your data will work, even if there's no loader for it. So.
Awesome. It looks like we only have one more question from the audience, from Alex today. He says, I have proprietary data. Can I still use GPT-4 as an orchestrator, agent plus SQL queries, but a local model as the one that gets the local context? I have proprietary data. Can I still use GPT-4 as an orchestrator, but a local model as the one that gets the local context?
The short answer here is no, because I believe the concern would be that you're going to leak that proprietary data to OpenAI. If it's the case that you don't care about the potential leaking of SQL data, then you can use the service context we talked about to only use the GPT-4 model to create SQL queries. You're still exposing that SQL data or metadata for sure. So it's important to know that and to trace how the information is processed. But you could use the rest of the stack, so the orchestrator as well as the retrieval engine, with whatever in-house model you have. So it is possible to use GPT-4 for what it's good at. You have to expose some of your data, though. If you use it as the orchestrator, it's going to leak context from your proprietary data through the retrieval process. So while it is true that it's not going to see all of it, or it's not going to see a majority of the context, you will leak some context. And so I would, from a security perspective, that's a conversation that you want to have with your security team and with whatever data contracts you have.
Nice. Okay, well, follow up from Alex. How would you approach summarization of long documents, longer than the model's context window, using local, aka small-ish model? Would you use a hierarchical index?
You could. There's like 1,000 ways you could approach that. You could just employ naive summarization. You could break the chunks up into smaller chunks. You could use a better packing method for your context. I would say that it depends on why you want to summarize or how you want to summarize, I suppose. But without more context, I would say there are a number of different ways that you can handle summarization. Absolutely, yeah.
Nice. Okay, very cool. Well, it looks like that's all the questions from our audience right now. If you do have questions, the Slido link is in the description on the YouTube box. But what I'm going to go ahead and do is I'm going to ask you a key question, Chris, that I think everybody's asking right now. When you think of LangChain and you think of LlamaIndex, do you have a preferred learning path that you'd recommend for people? And how do you think of the difference between these two tools? I feel like they're the same in a lot of people's minds.
Yeah, I mean, LlamaIndex is easier to use, straight up. It's more limited, but it is easier to use. It abstracts away some of the stuff that LangChain doesn't, and it abstracts it very cleanly. So yeah, I mean, ultimately, if I were to start, I would say LlamaIndex right now. But you're quickly going to run into situations where you're like, oh, but I need that LangChain power, right? Like, so it's kind of dependent on your use case and the complexity of the project. But I would say, for the most part, start with LlamaIndex. And I have to say my line, it's like, do the dance, right? So you should build with the tool. That's how you should learn it. I also know some folks that run webinars and offer resource on these things. It might be us. You know? So, but no, the best way to learn these tools is building projects with them. End-to-end projects is always going to be my recommendation.
Yeah. Build. All right.
Build. That's right.
Yeah. So we have just a fun question to close it out with, Chris. Can Chris out yell a dozen hockey fans? I can imagine him in a brawl. Yeah, I think a lot of us can. Yeah. So, Chris, the Phoenix jersey, rocking it today. Thank you, Data Phoenix. We really had a great time. I'm going to go ahead and sort of close it out here. So thank you, Chris, and thank you, Dimitri. Thank you, everyone, for your participation. This brings us to the end of today's event, brought to you by AI Makerspace and Data Phoenix. Our community at AI Makerspace is just getting started, and we're excited to announce our first ever 4-week live course on LLM Ops. LLMs in production, which will kick off August 14th, 2023. It will include deep dives on the hottest tools out there, including LangChain, LangSmith, LlamaIndex, Chainlit, and more. We are hype, not just about offering the latest and greatest tools, but we've also got some surprises in store for our inaugural cohort. It will be unlike any bootcamp you've ever been a part of. So feel free to apply today. Also, please give us a follow at AI Makerspace on LinkedIn and YouTube, and at AI Makerspace on Twitter. Until next time, we will keep building, shipping, and sharing, and we hope to see you do the same. Dimitri, thanks again so much from AI Makerspace, and we really appreciate the platform at Data Phoenix. It's been a blast.
Yeah, thank you, Greg, for this cool presentation and cool sharing your knowledge, and I hope your community will grow and we can collaborate together and do more interesting events, not online but also offline.
Yes.
So thank you for this presentation, and thank you for all for that you was with us. Please not forget to subscribe to our YouTube channel to see all our webinars, and see you next week.
All right. Bye, everyone.
Bye.